Hello and welcome to Fresh Thinking by Snowden Optiro, a podcast where we delve into the technical aspects of the mining industry. My name's Tarrant Elkington, General Manager for Snowden Optiro here in Perth. Today I'm joined by Markus Dammers from Metso, joining us from Germany. He is the Director for IPCC and Conveying for Metso. So thanks very much for joining us, Markus.
Thanks for having me.
Today, we're actually going to talk about a paper or two papers that we worked on together on the area of IPCC, and particularly focusing on a rapid screening tool for IPCC potential viability. So we thought it'd be good to have a chat about it and talk about what we did and some of the outcomes that we got from that. So hoping you find it interesting. But to start off, Markus, maybe you could just talk about some of the idea to do the paper in the first place.
Yeah, so the background is really we have been involved in some studies together, and the problem I see when it comes to IPCC and evaluation of IPCC, there is really a lot of options. The question is always, do we go in-pit? Are we ex-pit? Do we go for a fully mobile system? Do we go for a more semi-mobile system, or is it permanent installation, more fixed? Do we where is the best location really? How deep can we go in the pit? When do I relocate? All this stuff. It is just the what all these scenarios are missing is you need some kind of macro and economic perspective early on, right? To do a informed decision of which scenarios you are targeting in your next study stages. Yeah, so you need some framework in the end to kick off more detailed studies early on. So and that was the idea, right? So to come up with a model which helps you in decision making, really.
So when because typically somebody wants to evaluate whether IPCC, or let's just clarify, we're talking about In-Pit Crushing and Conveying.
So this model,
it's IPCC.
Yeah.
Often it would take you a long time to evaluate a single scenario to see whether it was going to work, right? And you might not want to do that, right? If you go down the line and see, look, this just doesn't work for this project. You want to figure that out quickly because you've got other options that you want to potentially consider, right?
Yeah.
So if we could come up with something that was really quick at helping you do that, then that would be quite useful.
Yeah, and the thing is, there are a lot of rules of thumb around early papers. Not saying good or bad. It is just the inputs are so different in different countries or locations. So when it comes to diesel pricing, electricity, so is there hydropower? Yes, no. So all these things. What is cost for labor? That are the main drivers, right? Which flips the coin to the one or the other in the other direction. So.
And I think, like, of all those rules of thumb, there might be like 10 of them.
Exactly.
No project generally will ever tick all of them. So it's about the trade-off between those parameters. And I think we've talked about some of those general factors in previous podcasts, right? So it's trying to get a tool that can quickly do that.
Yeah, so what do you think? Could you tell me something about start of the model and its origins? How did it start from your side?
Yeah, so I guess it initially started when I was doing an assessment for a mining company, and they were looking for, look at all of our projects, say, could IPCC or other electrification technologies be potentially viable for each of our options. So we had to do a quick assessment, and initially we were just going to look at it against those factors or rules of thumb. But I thought, no, well, it's actually a reasonably simple, to conceptualize a quick spreadsheet that you could put together to plug in those important factors and then see if there's a potentially economic case. And so that's what I did initially. And we were using, from our side, we were using some generic parameters that the best that we understood at the time. but I think when you came along, there was the potential to improve that. So.
Yeah. So the problem really is same here as I mentioned before with these generic inputs. The devil is in the detail, right? So in IPCC, everything is really about the idea is to reduce truck haulage as much as possible, not really to eliminate, but where's really the sweet spot to locate the crushing plant. And everything in the end is about the capacity, the horizontal and vertical transportation, the conveyor route in the end, which makes it up. Yeah, so look, the main parameters in IPCC evaluation is really the capacity of the system, so throughput, and the length and lift of conveyors or the truck route in the end. So, and this has to be dynamic. Otherwise, it doesn't make sense. You cannot do a proper evaluation without having this, because there are so many fluctuations, and especially in conveying or materials handling, you have enormous economies of scale, right? So going from smaller capacities up, it's really a logarithmic curve always. You just have to avoid bringing in, for example, a second crushing plant or a second conveyor line. This would be a massive jump in capex, of course, right? So, yeah, there are some things which are important for the model early on.
And I think where it was really good you coming in to the fore was actually adding some realism to those parameters, because here we're trying to, as you say, we're trying to decide between trucking and conveying. So clearly the capex and opex of each of those items is vital, is getting those right in terms of which one's going to be better. There's no point in underestimating one by 50% and overestimating the other by 20 and making an incorrect decision, right? So even though we were trying to build a reasonably simple model, it should be based on the best inputs and the best simplifications, using your 80-20 rule that you possibly could.
Yeah, that's right. There are many other things. I mean, that we can, from our side, we can handle the equipment side very well. But of course, there are other things we have to, let's say, bring into the model, like all the infrastructure needed, all the auxiliary systems needed, not only for conveying and crushing plants, also for trucks in the end, because it's also not so easy just to add 30 trucks into your operation, right? It's also a major undertaking in the end. So, and yeah, so all these aspects have to be modeled and be part of this early investigation to see the full picture. That is what I mean with we need this macro perspective on the economics and see what are the drivers really flipping the coin to the one or the other side. So it doesn't, for example, it doesn't make a difference if the crushing plant is 1 or 2 million more or less expensive.
Yeah.
Because these projects always come along with a major investment, right? So that is, you will see this very quickly when you are playing with the numbers.
Yeah. So perhaps it's worth moving on to the model itself, and I guess maybe to explain a little bit about the analysis that we do. So firstly, this is like an Excel tool. The second point is that what we're trying to do is figure out what the economics of the difference between putting IPCC into an operation is versus a trucking operation. And those economic analyses are the same for most evaluations, but we're looking at a difference to develop an NPV or NPC, an IRR, internal rate of return, a payback period for the capital investment that we put into this project. That makes it different than trucking, because trucking can also come with capital, as you say. There's new new equipment can be a significant outlay, and we have to make sure that when we do that evaluation, that we are not there's no need to include costs that are common for both um, uh, IPCC and trucking, right? So drill and blast, potentially, overheads, things like that. but we need to include the things that are going to change or be
Yeah.
different from
Differential.
yeah, yeah. So, and that also depends on whether we're talking about IPCC for ore or for waste, right?
Yeah. Yeah, I mean, especially for waste. I mean, for ore, it's easy. You just compare a truck route with a conveyor line.
Because the crusher is common, right? You're going to have the crusher anyway.
So that you need the crusher anyhow, and also the cost of stockpile and the stacker or whatever the stacking system is, it is part of the base case anyhow. So and in the end, the ore and that is industry standard. The ore IPCC scenarios is just truck versus a conveyor line. You know? The question is, expert is clear. How close do you get to the pit, and is there potential to go in pit, and where, and are there requirements to relocate at one point in time? On the waste side, then here is really, it is more complication in the end, and in the end it's harder to make it economically viable, because you need additional crushing plant, because you have to make it conveyable. That's clear. But also on the tail end, you need a stacking system. Yeah, and that is not just a spreader you add there. You need a series of shorter conveyors, sometimes bridges, to come along irregular shapes. Yeah. So and this makes up a waste system in the end. It makes it more complicated, and as I said, that's harder to overcome. And this has to be modeled as well, of course.
Absolutely. One of the things that was really important here was that you did some great work on trying to come up with a simple model for estimating the capital for the crushers and the conveyors themselves based off of various factors, so that we could put it into the model. Can you tell us about that?
Yeah, so in we decided some years ago already to come up with a structured approach to the industry. So not only offering crushers, so equipment, also offering full systems like crushing plants, conveyors as well. But we really productize this in a way. So we build up a library of standard modules for different crushing sizes, can be fed by different truck sizes, and so on. So we come up with a kind of a matrix and standard modules. This enables us to be very fast in budgeting these systems in the end, right? So for this study now you're talking on, or what kicked off, I came up with some generic inputs. I came up with a data set of different crushing plants of a similar configuration, of course. But I modeled it in a way that you cover different capacities from, let's say, 5,000 to 15,000 tons per hour. Same with conveyors, right? So the conveyors even more complicated. The crushing plant is easy; it's just different crusher sizes with configuration, and you're good. But on the conveying side, it's more complicated, because the length and lift component is has an enormous impact on the capex, of course, plus the capacity. That are the three things you need. I mentioned it in the beginning. So what we did then, I think was nice, also came up with more than 60 data sets, different capacities, lengths and lift combinations. And out of this, we did some multivariate regression analysis and came up with something like we called an equivalent flat conveyor length, similar to an equivalent flat haul.
Yeah.
We know from industry, and then when we were talking about truck haulage, right? So, and with this, really, we have the dynamic input we need to come up to, nice modeling, optioneering, sensitivity analysis, which we did then.
Yeah, and I think so. We not only use that data set to work out the capital cost of a conveyor, but also for the power consumption, which is also quite important. And and the power component is much more sort of sensitive relatively to the lift, than the capital is, right? So
Exactly.
so that was quite an interesting thing. The other part that I think is interesting in that modeling was looking at excavation costs, because I think that's something that we miss in some of these evaluations, and going in pit, and what that means for the actual the cost or the evaluation of the case. So that's one thing that we developed as well, was a simple tool for putting in the dimensions of the conveyor, the amount of ramp, I guess, additional ramp width you need for it, as well as the excavation for the crusher pocket and whatnot. And that can climb pretty quickly to plus 100 million tons of material if you try to put a conveyor, try to put a crusher deep into a pit, right? And so that's, sometimes that can actually swamp the cost of the cost of the equipment.
Yeah, so especially we in this case I think we have been really conservative, because we estimated or we assumed a conical pit, and yeah, just as pits are, we should reverse cone in the end. The deeper you go, there's an exponential increase in the stripping ratio and in the waste removal, right?
Yeah.
So but in some cases, so good for now, but that could be a potential improvement, because in many cases, if you want to go in pit, you look at your existing life of mine plan and see, is there maybe an area which is not exposed to
so much waste expansion.
Exactly. So is there a saddle coming up, stuff like this? Yeah.
Absolutely. So with that model, I guess we can model it for very quickly and simply for a single scenario, but because it's parameterized, we can
Exactly.
put it in data tables and see what happens with lift increases, length, diesel price, power price, any of those parameters that you want to run, you can plug into the model, right? Which makes it quite useful for those very quick sensitivities, heat maps for where things could work.
Yeah.
So we for the paper, we put in a generic a case study, where we sort of picked kind of average country level costs, sort of typical
average everywhere.
Yeah. So
average material properties, not too hard, not too soft.
Yeah.
Densities, normalish.
So I think the initial goal was to do something that would give the rule of thumb for the industry, that they could go and pick off an empirical chart, but I mean every mine is different, but really just to show the typical results that you could get, and we tested it for like an ex-pit waste, an in-pit waste scenario, ex-pit ore and in-pit ore, right? And we looked at ranges of throughputs, distances, lifts to see what would happen. And so the results were, I guess, intuitive in a way, but interesting.
Yeah. Because you see the numbers, it's quantified and
Yeah.
not guessing anymore, right?
Yeah, absolutely. So I think the first step was we looked at the kind of obvious one, right? So the ore, ex-pit, right? So we're just comparing trucks versus conveyors, as you said, on a single run. And in that case, the IRRs were always very high. It didn't really matter how long you make it, what lift there is or whatever, you would still get a very good investment case, because really that's just about bringing your crusher as close to the mine as possible, right? The complicator came when you would go into the pit, right? So that was one interesting thing. When you think about ore, we're going to crush it anyway, so we don't need to pay for it. But then when you start going deeper into the pit, we start getting extra excavation costs. So that starts to net out some of the benefit that you get from putting the conveyor into the pit for ore, right? So the IRRs that we were getting there were reasonably insensitive, I guess, to depth. They were still generally positive, but didn't really increase as you got deeper into the pit.
Yeah, it was interesting, because in the end, you see, we have the model, what we explained before. We have the small model behind how additional excavation gets into the in-pit scenarios. And there is more an exponential curve, as I mentioned. And exactly this curve you were able to see later on in our heat map, where we report IRR against capacity, length, and lift. Right, so that was interesting to see. And as you said, so it can be possible, even 100 to 300 meters in the pit. So why not? But that is also really what I learned. There is a lot of misconception and also marketing around for many people, not OEMs, but also some consultants or whatever, where you see render on pictures where the crushing plant is at the bottom of a pit, exactly there where where it's ended, and you start a new pushback, or a new pushback is coming from another wall, right? So it is kind of interesting how these renders, because that is nothing you would normally recommend. Put your crusher in the deepest part of your pit.
Yeah.
Yeah.
So there's always this trade-off to make, and you need to have the available tons. I think from the ore, as you said before, the waste is a much more challenging business case, because there's more capital and more operating costs that we need to overcome. So when we did that, when you look at the sort of the X-Pit case, you needed pretty long distances and lifts in order to justify the capital and capacity. So capacity was a pretty critical thing. I think we looked at 20 million tons, and it was generally pretty, not all that attractive. When we went to 90 million tons per annum of waste, then we could bring the lengths that we needed to make it an economic proposition down, right? So that it was possibly going to work. But in most cases, it's very limited for waste IPCC. Only in the best setups, I think, it shows.
Yeah, that also here, that was never a secret, but it was good to see some numbers behind this as well. Because I mean, we are dealing regularly with waste IPCC systems. That is something that's always studied, should be, in my opinion, right? Because many pits, they're expanding so fast. They have been relocated, also built a new concentrator somewhere. There is a limitation to dispose of material, especially in mountainous areas, to dispose of your waste directly around the pit. You have to, it has to be conveyed around the mountain, or some, at least at far more distance, and then it makes sense, right? So waste IPCs need more distance. Best case, bit more lift as well to make them economically viable. But yeah, that was an interesting take as well.
Yeah. So I guess that's where we got to with the case study. What do you think's next for this tool? I mean, I guess.
Yeah, for the tool, I mean, I would like to use it a bit more. That is really something we should focus on. I think that the tool still runs with a lot of assumptions. That's what it is. So one example I mentioned with additional stripping you have to do when you have the in-pit scenarios. So you can that is extremely conservative. Sometimes you eliminate this option in a way, but yeah, as said, so there are sometimes areas or a setup where you really can, and you can make this input a bit more dynamic and not so strict. Another one would be mainly that, I mean, that is a detail, but we had to assume some, because we came up with the sensitivity analysis on length and lift and IRR, as I said. So the longer we go, we subdivided the lengths in conveyor flights.
Yeah.
Right. So there was a logic behind. So, for example, a 10-kilometer conveyor was not one flight, right? So we subdivided this into 3 flights, for example, just to put a number. So also here, that is an assumption which is not valid for every project, right? So that could be, there should be an input for this maybe, right? So a couple of things like this can.
Yeah. I think, I mean, it's a model that's usable as it is. The outputs will always be better if the inputs are better, so we can always refine every aspect of that to make it more realistic, right? So, and I think as you say, I think the next step is really to apply it in more situations. So I guess on that note, we'll probably close there. But thank you very much, Markus, for joining us on this podcast.
Yeah, thank you very much. It's very interesting.
Yeah. So and of course, if you are interested in the tool or applying the tool for your operation, please feel free to reach out to myself or Markus,
Absolutely.
then we'll be more than happy to talk to you about it more, and and how it might apply to your operation. Thanks for joining us on this episode of Fresh Thinking by Snowden Optiro. Please, if you enjoyed the podcast, subscribe to us on whichever podcast platform that you go to, and we look forward to seeing you on the next episode.